Okay, so um, in terms of actually configuring multi-area OSPF, the good news is that there are no new special commands to learn. You're just going to create the routing process, create your router ID. Of course, if there's not a router ID, there had better be either a physical IPv4 address or a loopback address that the router can use in place of said router ID. Though, honestly, a statically defined router ID is the best possible solution. You go into your, you create your your routing process, you give it your router ID, and then you begin providing your network statements. Now, these three network statements might look a little weird because, as you'll notice, your networks are 10.1.1.1 10.1.1 O.O.O.O. What this is doing essentially is telling the router whatever network this interface is in, include that. This is kind of there's a thing called a host only route. Um, you can actually create static routes like this, where you create a route to a specific address, and the mask for that route is 255.255.255.255, basically the /32, which you'll actually see in your routing table if you do show IP route. Once you've configured your router, you do show IP route. You'll actually see two lines in that routing table for every interface, for every network. One for the network itself and one for the interface. Um, pardon me. So instead of looking at the C line, the connected line, you could look at the L line, the local interface line, and do it this way. The problem with doing it this way is that if you go back and look at your running config, there's not the correlation between the networks you're trying to build and their size is not immediately obvious. It'll get it done, but you may not be able to look at these and realize, wait a minute, I was trying to declare a /24 and I accidentally declared a /25. Maybe that's why things aren't converging correctly. So you can do it this way. I don't advise doing it this way, particularly when you're first learning how to do this. Now, as we discussed in before, now once we start talking about multi-area OSPF, we have to talk about roles. One of those roles is the area border router, ABR. A router with network statements or interfaces in two different areas is by definition an ABR. It can also be other kinds of things. Say, for example, router 1 and router 3. Because they've got an interface, they've got networks or interfaces in other areas, and networks and at least one interface in the backbone area. They're both ABRs and backbone routers. Now, R2 has got all its interfaces in the backbone area, so it's an internal backbone router. So pay close attention to that nomenclature. Now, let's talk about V3. Okay, so V3, the V3 has the same dynamics with multi-area OSPF as it does with single-area OSPF. You create the IPv6 routing process, you give it a router ID, you exit. You go into the interface ID, and you start assigning interfaces to areas. This allows us to not worry about trying to type in all those long, complicated, easily typographically mistaken IPv6 prefixes. You don't even have to worry about prefix length. Is it a /64 or /48 or /52 or whatnot? No worries. Just go into the interface and tell it which process and area it belongs to. Say IPv6 OSPF 10 area 1 or IPv6 OSPF 10 area 0. Router 1, just like the previous topology, and these two topologies are functionally equivalent with each other. They just have a different number of loopback addresses involved. Or actually, this one is not. Oh yeah, these are not loopbacks at all. I went the wrong way with that. Anyway, so router 1 is an ABR and a backbone router. And it's also got interfaces in a regular or non-transit area. And it's got transit area interfaces. Router 2 is of course entirely a backbone internal router. So let's talk about verification. There are a lot of show commands you can use. Basically, and the fun thing is any show command you can run for OSPF v3 for IPv4 you can do with OSPF v3 for IPv6 just by changing the IP to IPv6. Show IP OSPF neighbor to make sure your neighbor adjacencies are right. Show IP OSPF to look at the process itself. Show IP protocols to see what it thinks it's doing. This is particularly useful if you're trying to figure out if your passive interfaces are in the right place, or if you're hearing from the sources you expect to hear from. The thing to remember when you're using all of these verification commands is that they are most useful if you have some idea, have a clear and reasonable expectation of what you ought to see. So, because if you just pull up the show commands and you don't really know what you're looking for, the problem may just jump up and say, "Hey, here I am, solve me." But if you don't know what right is, how do you know what wrong is? This is why it's so important to have network baselines and things like that to know how the system ought to behave. So that when things begin to slide off normal, you will notice it. So we've also got show IP OSPF interface that'll tell you what the interfaces are doing. Show IP OSPF interface brief is also very useful, but unfortunately does not work in Packet Tracer. This is one of these commands which Packet Tracer just doesn't implement, like show run interface, unfortunately. So if you have lab instructions that say to run show IP OSPF interface, and you have to run that lab as a packet tracer instead, just understand you're not going to be able to do that. We've got show IP OSPF route, show IP route OSPF. That'll show you just the OSPF routes in the routing table rather, and then show IP OSPF database. If you really want to look at everything it has received, you can look at that. Notice that there's no topology. This is our best way of looking at the topology table. You look at the database and it'll figure out from there. Let's talk about some general settings verification. Okay, show IP protocols will give you basic OSPF status, the number of areas, the number of networks it is routing for. It'll even show you what masks you use to declare those. It'll also show you your routing sources, the last update, etc. And then show IP OSPF brief before if you can run it, will show you your interfaces, your process ID, your area, the address and the mask. Notice in show IP protocols, routing for the networks, you have the networks you see there in show IP protocols. Those are the way you built it in router config mode, when you were initially doing the configuration. So if you use host masks 0000, that'll show up there. But when you look at show IP OSPF brief, you'll see the address and the actual mask that is in use there. This is one of the reasons I suggest not doing it this way, so that you can look at your show IP protocols and your show IP interface brief, show IP OSPF interface brief, and the relationship is unambiguous. You should be able to see the same thing in both places. Say, for example, you look at, and this will help you figure out. Say, for example, you did accidentally declare a network, a /25 network when you implemented a /24. You look at these two pieces of output, you realize the discrepancy, and that can be an important clue. You'll also see their cost and their state and the number of neighbors they have. Now, these two interfaces, which are DRs, they've elected themselves as the designated router on that Ethernet network. They have no peers, so they have no neighbors. They're DRs, but they're not doing any good. The real relationship, the one that really matters, is this P2P state between serial 000 and the neighbor. So let's look at the routing table. So show IP route OSPF begin gateway. Sorry about that. This is something this is one of those things you can do with v4, but not with v6. Like I said, that nearly everything you can do with show IP route you can do with v6. This is the difference, because the IPv6 routing table is a little bit different, and you don't have a line that says begin gateway. If you want to skip all that route origin code stuff at the top, if you need to see that because you can't remember what they all are, or you don't mind looking at it, you can skip the pipe begin gateway part. But if you really just want to skip to the important, cut to the chase, get the important stuff, you can do show IP route OSPF pipe begin gateway, and then you will see the gateway and only your OSPF routes. No static, no locally connected, no other routing processes, just this. And as we discussed before, the O represents an OSPF route, and the IA represents an inter-area route. That is a route learned from another area via an area border router. And then we can also look at the LSDB, the link state database. That's what the OSPF command, show IP OSPF database command gives us, is the LSDB. You can use this to figure out what links you're learning about, what routers you're learning them from, how long they've been there, checksums, link states, all of it. Let's also talk about OSPF v3 right quick. So, like I said, you can do most of the same things. Show IPv6 protocols, interface brief, route OSPF, except that there's no pipe begin gateway. The difference here is, really there are a lot of differences. You'll see the interfaces being included in each area, the router ID, you'll see passive interfaces, you'll see the source routes. Now the source codes are a little bit different in v6, whereas with v4, sorry, the origin code, sorry, source code means something completely different. With OSPF v2, OIA indicates an inter-area route. With OSPF v3, it's OI. OI says it's an inter-area route. O is just an intra-area route. And again, you've got your interface and interface brief. You see your costs, your interface IDs, neighbors, all of it. And we've got some packet tracers. V2, V3. We've got a couple labs. This is the 9228 lab. This is 9229. I've done a video for 9228 already. I will be doing a video for 9229 soon. Thanks for watching.